Okay, so there was this German scientist almost 100 years ago named Alfred Wegener, and Alfred Wegener had this theory that no one had thought of yet. His theory was supported by three big pieces of evidence. The first was that when you push the continents together like so, they seem to form a puzzle that fits together perfectly. This applies to Europe, Asia, and Africa. His second big piece of evidence is that dead animals like the rhinoceros can be found in large quantities on both Africa and South America. Now, how is it possible that the rhinoceros had moved from Africa to South America? It couldn't swim across the ocean, and it couldn't fly across the Atlantic Ocean, so how is that possible? Alfred Wegener's last piece of evidence was that when you push the two continents together, that land masses seem to match up. In this case, a mountain range that starts on South America ends on Africa. This also applies to other continents. Rivers and valleys and deserts can all be found going across continents. Alfred Wegener believed that at some point in time, all the continents that we know today had at one point made up one supercontinent called Pangaea. That supercontinent called Pangaea had then split off into all the separate continents that we know today. When Alfred Wegener released his theory, the big question on everybody's mind was, how? How is it possible that these continents could have moved? Everybody seemed to be asking that, and Alfred Wegener didn't know. There was no force known at that time that was powerful enough to move these huge land masses, and so his theory was discarded. Alfred Wegener died in 1930, and still his work had not been accepted, but others continued to do research into what he had started. People started to map the Earth, the earthquakes that happened on the Earth. They started to see lines and shapes that developed. As they continued to map these earthquakes and other occurrences, those lines and shapes became more evident, until eventually scientists saw that there were shapes that were on the Earth. Scientists believe that these shapes are really plates that are underneath the Earth. But before you can understand what that has to do with continental movement, or continental drift as it is called, you have to understand this. There are different layers of the Earth. The part of the layer of the Earth that we live on is the crust. There's the continental crust, which is what continents are made up of, which is very thick, and the oceanic crust, which is less thick. Both of these are made of rock. It is the coolest layer of the Earth, which is what allows us to live on it, and it is part of the lithosphere, which is an area where those plates I told you about were. The next layer of the Earth is the mantle, which is the largest, making up 83% of the Earth. It is made of rock. It has the asthenosphere, which is an area of it's a taffy-like it is a taffy-like thing that can flow when heated. It is made of hot liquid. The rock inside of the mantle is so hot that it has become molten rock. After that is the core. The outer core is so hot that it is liquid. It is made of iron. It is liquid iron. The next layer of the Earth is the inner core, which is compressed by so much matter it is solid. It's very hot. It is so hot that it heats the outer core and the mantle, and it is made of iron and nickel. Now, before you can understand what that has to do with continental drift, you have to understand this. When a candle is beneath a glass, the candle will heat the water at the bottom, forming what we call a convection bubble, which is sort of a bubble of hot water. For the sake of our demonstration, let's say that this dyed red water here is the convection bubble. The convection bubble will then rise to the surface and then disperse back to the bottom. But it will rise because it is heated, and when liquid is heated, it becomes less dense. And we know from the law of buoyancy that when something that is less dense is on top of something that is more dense, it will float. A less dense object will float on a more dense object. And what that has to do with continental movement is that the inner core is so hot that it forms convection bubbles in the mantle. And when the convection bubbles in the mantles rise, they collide with the plates. And when it collides with the plates will move. They move in certain ways. One way is a convergent boundary, which when the oceanic crust and the continental crust slam together, and because the oceanic crust is weaker, it will go deeper into the Earth. Another way is divergent boundaries. Here, when a convection bubble collides against the plates, they'll spread apart, and that will cause plates and land to move. Then there are transform boundaries, which is where two plates grind against each other in different directions, which can cause all of these can cause volcanic eruptions, earthquakes, tsunamis, and most importantly, can cause continental drift.